All right, so chapter 1, video 2 is all about multiplying matrices. In your book, this is section 4.2, by the way. Multiplying matrices. Now, this is going to be completely different than when we were adding and subtracting and even scalar multiplication of matrices. With addition and subtraction, they needed to be the same size. With multiplying matrices, that is not the case. And in fact, it actually has a very strange procedure. Here it is. You ready? Multiplying matrices is the sum of products, the sum of the products of the row entries of the first matrix so it's going to be the sum of the products of the row matrix of the first matrix, row entries, with the column entries of the second matrix. All right, now, Smith, I don't even know what you just said. I know. Here's the thing. The sum of the products of the row entries of the first matrix with the, I'm going to add a word here, corresponding column entries of the second matrix. Smith, that didn't make it any better. I know. Let's do an example here. Sorry, I got interrupted there for a moment. I'm sure there was a weird silence there. So take a minute and write this problem right here. There are two separate matrices. Now, notice these are definitely not the same size. In fact, the size of this first one, go ahead and press pause if you need to keep copying, but the size of this first one is, this is a 3 by 2 matrix. And this one, what's this one? This one is a 2 by 3. Now, first of all, in order to be allowed to multiply matrices, the two inside numbers have to match. In other words, the number of columns of matrix A, I'm going to call this matrix A, and the number of rows of matrix B have to be the same. Rather than saying that, the two inside numbers have to be the same. And then that means that our solution, our answer, is going to be a 3 by this much 3 matrix. So, for example, what I like to do is, since I know our answer is going to be a 3 by 3 matrix, I like to do this so I can see what my answer is going to be. I know what you're thinking, Smith, this is some wonky stuff. How is that going to happen? All right, so here's what's up. We're going to multiply matrices. It's the sum of the products. Products is the key word I want to focus on now. Of the row entries of the first matrix. So we're going to be talking about the rows here with the column entries of the second matrix. So here, this entry right here is the first row, first column, right? So first row, first column. So we're talking about 8 and -3. We're going to do 1 times the corresponding first position here in this column. 1 times 8 is 8. Plus, because it's the sum of the 2 times -3, which is -6. All right? It's the row times the column, and it's the sum of those entries. I know, it seems weird, right? Tell you what, let's talk about this entry right here. Let's talk about row 3, column 2. To find that entry, we're going to do, let me erase these other things that we made here. Row 3, column 2. So, row 3, we're going to do negative 3 times 4, which is negative 12, plus, and then we just take the next entry, 5 times 0, negative 12 plus 0. Kind of seeing it? Maybe, Smith. Let's talk about this one. Let's talk about this guy right here. Let me erase these works. This is row 2, column 3. So, row 2, column 3. We're going to do 4 times 1 is 4 plus 36. Right? 4 times 1, and then the 6 times 6. 4 plus 36. I'll tell you what, take a minute to pause and see if you can come up with the rest of these entries. Remember, row times column, and that will give you the entry. All right, so go ahead and pause it and give that a shot. And I will fill these in just a moment. All right, hopefully you checked yourself, and hopefully you got these entries. Now, what that means, we simplify all of these, and our answer is going to be 2, 4, 13, 14, 16, 40, negative 39, negative 12, and 27. So, I know that seems weird, right? A 3 by 2 and a 2 by 3 yields a 3 by 3 matrix. Seems very strange, right? Let's try another one. Let me pause this and copy that one down. If you need to pause it, go for it. Otherwise, the size of this first matrix is, this is a 2 by 3. The second matrix is a 3 by 2. Now, are we allowed to multiply these? Indeed. 3 by 3, those match up. So our solution is going to be a 2 by 2 matrix. So before I even get started, I like to show what my answer is going to look like. It's going to be a 2 by 2 matrix like this. So if you'd like to pause it, give it a shot. Otherwise, I'm going to do the first one, and then I'd like you to pause it and do the rest of them. In fact, I'm going to do this one first. This is row 2, column 1. So let's go to our problem here. Row 2, column 1. So, and you multiply the corresponding positions and add them up. So 40 plus 0 plus, well, how about that? 0. All right, go ahead and figure out those other ones. I'll give you a moment to press pause and give those other 3 a shot. All right, so hopefully you came up with these entries. So our final answer is going to be 20, 21, 40, and 32. Hopefully you're starting to get the hang of this. I hope so. All right, let's do one more. And I'm going to show you why this works. Our last one. Write this one down. Ow! And once you're written down, let's do this. The size of this first one. Oh, that's a 0, by the way. That's not a weird 6. But actually, it doesn't even matter, because here's the thing. This is a 2 by 3. And this is a 2 by 2. So, the inside numbers, you look at the inside numbers to see if we're allowed to multiply. 3 and a 2. Those are different things, right? So, because these don't match, the answer to this one is we cannot multiply. We cannot multiply. All right, let's try another one. In fact, instead of another one, let's talk about why we multiply in this weird and wonky way. I'm going to pause this. You write down this word problem. A men's softball team and a women's softball team need new equipment. Assume the balls, gloves, and hats are equal price for either team. All right, so if we were going to inventory this, if we were in charge of making a spreadsheet of what we would need for both teams, we would need 2 rows. So we would need to talk about the men's team, and we need to talk about the women's team. And then we would need to talk about how many balls, softballs the men's team needs. So let's say, for sake of argument, let's say the men's team needs 6 softballs. And the women's team needs 4 softballs. And we're talking about gloves, and we're talking about the hats. Let's say that gloves cost, or excuse me, they need 3 gloves on the men's team, and the women's team, they only need 1. The women's team are squared away. They got 8 players who brought a glove, only 1 of them didn't. And then hats. All 9 dudes lost their hats, and then the ladies, only 2 of them need hats. The ladies are squared away. All right, well, the problem says that let's assume that the cost is the same. Now here's the thing, if we were going to multiply this by the cost, let's talk about, let's say that balls, gloves, and hats, don't write this part down yet. Balls, gloves, and hats, let's say balls cost, I don't know, $3, gloves are $10, and hats are $5. The thing is, if we were to multiply this, the way you would intuitively do is that this isn't a scalar, so we can't just multiply it by all of these, because there's different positions. That's kind of weird, right? So instead of, and also if you look at this, this is a 2 by 3. This is a 1 by 3. So by our original rules, we're not allowed to multiply these, because also it doesn't make sense just to take this and send it to both of them and get two different things. Instead, what we are going to do is, because this is a 2 by 3, this matrix would have to be a 3 by something. 3 by anything, really, right? Since this one ends in a 3, if we're going to multiply, it's going to be like this. So instead, it's going to look like this, a 3 by 1, in which case we said, oh, I forgot what I said. I think I said balls were $3, $10, and $5. I hope that's what I said. That's what's going to happen here. Now, what does that mean? What this means is that when we multiply this, rows times column, since this is a 2 by 3 and this is a 3 by 1, our answer is going to be a 2 by 1 matrix. So we're going to have 2 answers like this. So tell you what, take a moment and figure out how much each team is going to spend. And I will meet you back here in just a moment. All right, so hopefully y'all came up with $93 for the, wait, this is 93, yeah, dollars for which team? For the men's team. And $32 for the ladies' team. All right, so hopefully this kind of demonstrates as to why we have to multiply as rows times columns. Since the equipment is the same price for either team, the number of bats the men's team needs times the, or excuse me, not bats, we said that was softballs. 6 softballs times 3 means that they got to spend $18 on balls. They'd have to spend $30 on gloves, and they'd have to spend $45 on hats. On the other hand, the women's need 4 softballs, but it's still the same price. So you multiply this row times this column. Oops. And I know it's kind of a wonky way to multiply, but hopefully this kind of illustrates a little bit as to why we have to do it rows times columns. We'll practice a lot more with this tomorrow. Thanks for watching.